Okay, so here we have a polynomial division problem. Suppose we want to divide x cubed plus x squared minus 10x plus 8 by x minus 2. How are we going to do that? Well, the first thing we're going to do is write the dividend, the thing we're dividing, by the other thing. This is x cubed plus x squared minus 10x plus 8. We're going to put on that on the left here. And on the right, we are going to put x minus 2, the divisor, and then we're going to put in the quotient polynomial and then the remainder polynomial there. So this is the divisor, this is the quotient, which we're going to figure out. We're going to reverse engineer the quotient, figure out what it is, and then the remainder. The remainder could be 0 if this is a factor, if x minus 2 is a factor of this cubic polynomial there, or it could be a constant. It has to be a lower degree than the divisor, which is linear, so the only thing lower degree is a constant. It's important to note that if you have a higher degree divisor, like if you have a quadratic, then the remainder could be a linear term. It could be constant or linear. There are videos, though, where we talk about that in depth and the sort of theory behind it. Here, we're just going to do it so that we can see how to do it. What is our process for this? And we're going to do it in a way which is probably not what you were taught in high school, but it's actually exactly the same process, just the way we're going to do it. We're going to understand why we're doing it and why it works, and that is going to eliminate the possibility of errors. We're going to validate our work at every step so that we know 100% that we are correct. Okay, so how do we do this? We have x cubed is the first term of this, right? We look at term by term and we match the next highest power of x. So this is x cubed. We have an x here. The first thing that I put into the quotient is whatever I have to multiply by x to get x cubed. And that, of course, is x squared. These things, by the way, I always say, polynomials, they factor themselves. They divide themselves. It's factoring if x minus 2 is a factor, but they divide themselves. If we understand the process, there is no choice about what to do at every step, right? I have to get an x cubed here. This is the highest degree term, and it will be the product of the two highest degree terms from these ones that we're multiplying together. So there's no choice. I have to put an x squared there to get this x cubed. And then this one is matched. The x cubed is matched. But then we're not done with this, right? We have to multiply the x squared by that negative 2 as well. When we distribute it in, we have to multiply by everything. So we get a negative 2x squared popping out here, right? This is going to be negative 2x squared. And then we look at the next term, which hasn't been matched yet, because this so far, by the way, is the output of distributing in that x squared. We look at the next term, which is positive 1x squared, and we think, okay, we have so far negative 2x squareds. We need 1x squared. So how many do we need to add? How many x squareds do we need to add to negative 2x squared to get 1x squared? That's just saying, what do we have to add to negative 2 to get 1? I think the answer is 3. I'm pretty sure that if we add 3 to negative 2, we get 1. So the next thing that I put into the quotient is whatever I have to multiply the x by to get 3x squared. What is that? That is 3x. Right? That is what you multiply, because we add the exponents, of course, when you multiply the same bases. X to the 1 times x to the 1 is x to the 2. So we put a 3x squared. And then we get let's tally up what we've done so far, right? We have x cubed, which we wanted. Now we have a plus x squared, which is also what we wanted. That was the right number of x squareds. So both of these are taken care of. But again, we're not done with the 3x. The 3x has to distribute into both terms here, and it has to multiply by the negative 2. And what is negative 2 times 3x? It is negative 6x, right? So we have a negative 6x here. We can bring it down here and see the total output of our work so far, right? We have x cubed plus x squared minus 6x. All right. But how many x's do we need? Now we go back up here. The next term that we haven't matched yet is the negative 10x. We have negative 6x's, and I was only kind of doing this because it sort of mirrors the algorithm that you guys learned. We want to see the correspondence between the steps, but I'll keep this up here because below it I'm going to put what we need to get from the next round of this, right? To make negative 10x's. We have negative 6x's, and we need negative 10x's. So how many do we need to get out of the next thing that we put into this quotient? Well, we need negative 4x's. So I'm going to put in a negative 4x here. This is what we're trying to get. And then I think, okay, what do we have to? And this will make the Negative 10x is here. What do we put in there? Well, whatever we have to multiply x by, right, the first term, to get negative 4x, I think that is negative 4. I think that negative 4 times x is going to be negative 4x, and that's great. We can tally them up again, right? We're going to get x cubed, and these ones kind of cancel and become a negative 10, right? This is going to be x cubed plus x squared minus 10x. That's what we have so far, right? And all of these, I'll keep the colors the same maybe. All of these are the output thus far of this thing. But again, we have to distribute in the negative 4. We have to multiply it by the negative 2, and we will get positive 8. We get positive 8. And is that the constant we wanted? Yes, that is the constant we wanted. So that actually shows us that x minus 2 is a factor of x cubed plus x squared minus 10x plus 8. If this hadn't been 8 or something, if this had been like 10 or something like this, then in order to make the output equal to the left-hand side, they're equal to the dividend polynomial, we would have to make the remainder like negative 2 or something like this, right? The remainder is whatever you have to add to the constant output here to make it into this constant so that the left-hand side will be equal to the right-hand side. Here, it is 0. The remainder is 0 because we got the right constant. So that means that our division statement is going to be, put it down here where we have space, x cubed plus x squared minus 10x plus 8 is equal to x minus 2 times x squared plus 3x minus 4. We might have known that initially, right? We might be dividing this by x minus 2 because we had noticed that if we call this p of x, right, we might have noticed that p of 2 is equal to 2 cubed plus 2 squared minus 10 times 2 plus 8, which is 8 plus 4 minus 20 plus 8, which is 0. And then the factor theorem tells us that x minus 2 is a factor of p of x. And that's why we're dividing it by this. So if you haven't seen the videos on the factor theorem, do check them out, right? The factor theorem, polynomial division, and the rational roots theorem, those are our polynomial factoring toolkit. Any polynomial with rational roots, even if it's degree 3, degree 4, degree 5, etc., we can factor using these things. And this is a core skill. It's very important. One thing you might have been wondering about, again, why am I doing it this way? It's not the way you were taught in day school, in high school, probably. And the reason is that, again, this is the exact same steps. I think I mentioned this. But when we do it this way, we actually understand why we're doing what we're doing and why it works.